We have already studied Newton's first law of motion. Newton's first law tells us that a force is necessary to change the state of rest or state of motion of an object in a straight line. And what was the statement of Newton's first law? Every object continues to be in a state of rest or in a state of motion unless it is acted upon by an external unbalanced force. Newton's second law tells us the amount of acceleration that is produced by a force. And what was the statement of Newton's second law? The rate of change of momentum is directly proportional to the impressed force and takes place in the direction of the force. But the first and the second law given by Newton does not explain how force acts on an object. So, this question is answered by Newton's third law of motion. And what is the statement of Newton's third law of motion? To every action, there is an equal and opposite reaction. I repeat, to every action, there is an equal and opposite reaction. Now consider a book lying on a table. The book exerts a force which is equal to its weight on the table. This force is called as the force of action. So the force which is exerted by the book on the table is called as the force of action, and this force is exerted in the downward direction. At the same time, the table is also going to exert a force of reaction on the book, isn't it? And this force of reaction is in the opposite direction. Now what is the net force or the total force or the resultant force acting on the book? 0. So the book does not move. We have already seen this in balanced force. So in this example, there are two objects which are there, the book and the table. And there are two forces which are acting or which are in operation in this example. Which are these two forces? The force of action and the force of reaction. The force of action is exerted by the book in the downward direction. The force of reaction is exerted by the table in the upward direction. So what is one force called as? The force which is exerted by the book here is called as the force of action. Whereas the force which is exerted by the table on the book is called as the force of reaction. Also, we need to know that the action and reaction forces never ever act on the same object. So we are having two different objects. One is exerting a force of action on the other, and the second one is exerting a force of reaction on the first one. So these two forces never act on the same body, but they act simultaneously on two different bodies. That is, these two forces are present always in pair. Also, we find that the force of action and the force of reaction are equal in magnitude. For example, if the book exerts a force of 1 Newton on the table will also exert a force of 1 Newton on the book. So the forces which are exerted by the force of action and the force of reaction are equal in magnitude. But the forces are acting in opposite direction. One force is acting in the downward direction. The force of reaction is acting in the upward direction. So what happens because of this? Though the forces are equal in magnitude and they are opposite in direction, they do not cancel each other. Why? Because these two forces are acting on two different objects. While stepping from a boat, a man exerts a force of action on the boat. In turn, the boat also exerts a force of reaction on the man, helping him to step out of the boat. And what happens to the boat? The boat moves away from the shore due to the force of action which is exerted by the man. When a batsman hits a ball, the bat exerts a force of action on the ball. Thereby, the ball is projected with a greater velocity. At the same time, the ball also exerts a force of reaction on the bat, thereby slowing down the movement of the bat in the backward direction. When a bullet is fired from the gun, a force of action is exerted by the gun on the bullet. It is because of this force of action which is exerted by the gun on the bullet that the bullet starts moving in the forward direction with certain velocity. At the same time, according to Newton's third law, the bullet should also exert a force of reaction on the gun. So what do we see? The gun moves in the opposite direction with a very small velocity. Okay, so what is the force of action which is exerted by the gun on the bullet? The force of action, due to which the bullet moves in the forward direction. What is the force of reaction which is exerted by the bullet on the gun? The gun moves in the backward direction. Now we find that when the bullet is projected in the forward direction, it moves with a very high velocity, and this velocity is called as the muzzle velocity. Whereas the gun moves back with a very small velocity, that is, the movement of the gun is opposite to the direction of the bullet, and this small velocity with which the gun moves behind is called as the recoil velocity. If there are two electric charges which are separated from each other by a distance, and if they attract each other or they repel each other, still there is force of action and reaction which will be exerted by each of the electric charges on each other. For example, if there are two electric charges, one is a positive charge and the other is a negative charge. The positive charge exerts a force of action on the negative charge, and the negative charge in turn exerts a force of reaction on the positive charge, thereby helping them to attract each other. If there are two positive charges, that is, if there are two like charges, suppose there are two positive charges, then one positive charge will exert a force of action on the second positive charge, and in turn the second positive charge exerts a force of reaction on the first positive charge. So since these two charges are like charges, we find that the force of action and reaction which acts between both of them helps in repelling these two electric charges from each other. Motion of rocket is based on Newton's third law of motion. Now we know that in order for the rocket to be propelled in the upward direction, rocket fuel has to be present in the fuel tank, isn't it? And when the fuel in the fuel tank burns, then gases of high temperature and pressure are produced inside the fuel tank. So now these gases cannot remain in the fuel tank. So what happens is the rocket exerts a force of action on these gases which are produced in the fuel tank. What is the result? The gases are thrown or expelled in the outward direction from a small hole that is present at the tail of the rocket. You must have seen a small trail which is left behind whenever a rocket is projected, or you can see a rocket moving in the sky. So this trail of gases is left out from a small hole or a small nozzle which is present at the tail of the rocket. Okay, so this is the force of action which is produced by the rocket on the gases, thereby throwing the gases in the outward direction. Now in turn, the gases will also exert a force of reaction on the rocket. And what is this force of reaction? It is because of this force of reaction the rocket propels in the upward direction. So the motion of rocket is based on Newton's third law of motion. So once again, what is Newton's third law of motion? To every action, there is an equal and opposite reaction.